as we start lesson 8.7 now today, we're going to be, our learning goal is I can solve a quadratic function using the square root method. Now, note how I start these notes out, and this is huge. Some, why don't you put a box around that? Some quadratic equations can be solved easily by finding square roots. Not every quadratic function can have this applied to it. It's one of the easiest methods, but it can't be used for all of them, only certain ones, okay? So it's a good method to use when b is equal to, those of you who've been using it already, what do we want b equal to? To 0. We don't want any x terms in there. So it's a good method to use when b is equal to 0. So after you've identified maybe what a, b, and c are, you see that b is equal to 0, you're like, oh yeah, why go through all that work of solving this by factoring, or maybe by graphing, or another method? Let me use the square root method, because that would actually be the most efficient method, okay? Or when you have a factor times itself. That's the other time that this is a good method to use. If instead of it being multiplied out, it's in its factored form, and it's a factor times itself, then the square root method is a good one to use, okay? So let's do some practicing here. We have x squared equal to 121. If we moved that 121 over to the other side so that it was set equal to 0, what would the b value be?
Negative or negative or 0.
In other words, there has to be what in the problem for there to be a b value other than 0? What does the equation have to have in it? If it's a quadratic function, it has to have what in it to say b is something other than 0? X's, yeah, it has to have some x, just that x term. We have an x squared term, we have a constant term, but we don't have any x's, just like, like 3x or something like that. So this tells us that it is, our b is actually 0, so we're not going to move that 121 over in this case. We're going to leave it like it is, and we're going to take the square root of both sides, because what is the square root of x squared? What is the square root of x squared? X. What times itself gives you x squared, in other words, and that's what we want. We want x. So by taking the square root of x squared, that's how we're going to get x. Well, if we do that to that side, we also have to do it to the other side. So what's the square root of 121?
It's 11.
It's 11. Okay. So 11 times 11 is 121. You guys convinced Devontae that it's not 12. What's 12 times 12? 144. So we're going to go with 11. Okay, because 11 times 11 is 121. Are there any other numbers that, when multiplied by themselves, give you 121? No? I want everybody to go grab a calculator in the back. Let's go grab a calculator. You know what the neighbors by getting them, so we will all have to do that or whatever. But I want everybody to have a graphing calculator.
Oh, there is another one that equals 121.
Oh, there is.
Yes, there is. It's negative 11 times 11. The negative and negative.
The negative times a negative is also a positive. So if you have a negative 11 times a negative 11, would that also equal 121? Okay, so here's what I want you to go into your calculators, and I want you to graph this. Well, to graph it, here's what we're going to have to do. We are going to have to move that 121 over to the other side. So let's go to our y equals. I want you to put into your y equals screen, clear out anything that's in there right now. I want you to put in x squared minus 121, because we're going to get moved over. And then let's set this window. Okay, let's go to the window key. I'm going to set a good window. Go to the window key. So for x min, I want you to put in negative 15. Negative 15, not subtract 15, negative 15. For x max, I want you to put in positive 15. We're going to have the x-axis actually go by 1. So if the x scale is not 1 right now, make it 1. And then for the y-min, well, this tells me that the y-intercept is a negative 121. We gotta have it go down the way. So let's go to negative 125. Y-min, negative 125. And then for y-max, you know, I don't really need to see a whole lot above it, so I'm just gonna say 5. Let's put 5 for y-max. And then let's have that go by, oh, let's see. Let's have it go by tens. So y scale 10. Okay, so and then that x res, we're just going to leave it as 1. So here's what we all have, right? Negative 15, positive 15, 1, negative 125, positive 5, 10. Okay, press graph. Do you have a parabola?
Yes.
Is it opening up?
Yes.
Is it crossing the x-axis in one location or two?
Two.
It's crossing in two. So that tells us we can't be happy with just x equals 11 as a solution. Our other solution is maybe what Cody said, x equals negative 11. Let's go to the table and verify it. Okay? Let's go to the second graph, go to the table. Where x is equal to our positive 11 is y0.
Yes.
Okay. Well, then let's check out that negative 11. Go to negative where x is equal to negative 11 is y equal to 0. Yes. So we have two places that the parabola is crossing. It is crossing at positive 11 and it is crossing at negative 11. So we can't just say that it's x equals 11, it's also x equals negative 11. We actually have two solutions here. We have two zeros. We have two places it's crossing the x-axis. If we would have only put 11 as our answer, what would that have meant? What should the parabola look like? Now, you guys should be able to do this. What should the parabola look like? No, if it's only 11, what would it do?
Like that, the tip of it where it dips down is going to hit the 11.
Yeah, the vertex is going to sit right there at 11 on the x-axis. But that's not what's happening, is it? It's not sitting. The vertex is not sitting at positive 11. That would mean then there is only one solution, but this one has more than one solution. It has both of these. Here's how you will typically see it written, okay? Or I'm going to say you could write it like this. X equals a positive, negative, 11. That's the shortcut way of writing it. So you don't have to write x equals 11 and x equals negative 11. The shortcut way is to write x equals positive, negative 11. There are two solutions. Okay. Leaving those, that window in, I think we'd be all right just to try and graph this. No, I think I might have to change it up a little bit. Okay, we go back to the window key because we're going to try something. Go back to the window key. And you know what? Let's just leave the x min and the x max and the x scale what it is. And go arrow down till you get to the y min. I want you to change the y min this time to negative 5. The y minimum is going to be negative 5. The y maximum is going to be, let's see. Let's take that up to the, let's put 125. Let's put 125. So y maximum 125, and then let's just leave the y scale what it was. Okay. Press graph. Oh, wait a minute. We haven't put in our equation yet. Sorry. Go to y equals. Go to y equals. I'm actually going to have you put number 2 in right now. I want you to see what happens on the graph. We're going to move that negative 64 over to the other side, so this is set equal to 0. So in y equals, when you clear out the one we had in there and put x squared plus 65. X squared plus 64, yeah, we're going to get 5. X squared plus 64. And then press graph. What happened? So is it opening up or down? Is it opening up or is it opening down? It's opening up. Is it above the x-axis or below the x-axis? The vertex? Above. So could it ever possibly cross the x-axis? opening above the x-axis. It's opening up, and its vertex is above the x-axis. Can it ever come down across the x-axis?
No.
No. So what does that tell us about this one?
No.
Well, it is a parabola. Didn't you get one?
But a function.
Well, it's a function, yeah, because for each x value, there's still only one y value. Go to your table and look. For each x value, there's still only one y value, so it's a function. Well, it probably wouldn't be factorable. I might have to agree with that. Are there any zeros? No. If there are no zeros, can there be any solutions? No. So we would say no solution. We would say no solution to this one. So we're going to just write that right now. We're going to say no solution. But of course, you're not going to want to have to graph them to figure that out. So tell me, how do we know algebraically that there's no solution? So in other words, what we would try and do with this one is we would say, well, to get x out of x squared, I got to take the square root, right? And I got to get, then if I take the square root of that side, I got to take the square root of the other side also. So now when we try to take the square root of negative 64, go ahead and try that on that graphing calculator. Well, go take the square root, and don't use the subtraction key. After you press the square root symbol, press the negative key, and then 64. Oh, you can, if you do a second mode, it'll take you back to what we call the home screen. Second mode, it'll take you back to just the home screen, like the place where you do some calculating. And take the square root of a negative 64, and then show me what your calculator says. Square root is above the x squared key, so it would be second x squared. Error not real.
You can't take the square root of a negative number.
Why can't you take the square root of a negative number?
Because
Somebody passed that math law and we can't
just
break it.
it would happen.
Tell me why. Why can't we take the square root of a negative number? Gotta be a reason. Gotta be a reason this calculator is not cooperating with us. Oh, when you multiply to get a negative number, one has to be negative, Michaela says, and the other has to be positive. And square root means something times itself. So can itself be positive and also negative at the same time? No. So you can't find a number that times itself will give you a negative 64. So we say you can't take the square root of a negative number. You can keep trying. It's never going to work because you will never find a number times itself that will give you a negative. Because a negative times a negative is not a negative. A positive times a positive is not a negative. It has to be a number times itself. Okay, but I wanted you to see what the graph looks like when there's no solution. So if there are no zeros, there are no solutions. If there are no solutions, there are no zeros. It will not cross the x-axis, ever meet it. Okay, so number 3, the first thing we need to do in this one is we're going to get the x squared term alone, because if we get the x squared term alone, then we could take the square root of both sides. Are there any x's in this one? Just good old x's. Are there any bx's in this one? No. So that's why what we're going to do is we're going to add 25 to both sides. Because then we'll have 4x squared alone, and we'll have 25 on the other side. And there's actually 2 ways we can go about attacking this one. Okay? Is 4x squared a perfect square? Or in other words, is there something times itself that would give you 4x squared? 2x would, wouldn't it? Is 25 a perfect square? Yes. So we could go right to taking the square root of both sides. Let's do that first, okay? So let's try, if you take the square root of 4x squared, you're like, well, that'll at least get it to be an x. There's going to be a 2 in front of it, so that's kind of an issue. But right now, don't worry about that issue. If I took the square root of 4x squared, I have to take the square root of 25. The square root of 25 is 5. Oh, just 5?
Yes.
Just 5? and negative 5. Don't forget that. So you know what? We're going to do that little shortcut here that says, you know what? It's a positive and a negative 5. And why don't we do it on the other side? Because we only need to do it on one side or the other, okay? Because a positive then divided by a positive would be a positive. A negative divided by a negative would be a positive. And then a positive divided by a negative would be a negative. And it would all come out in the wash, okay? So you only have to do it to one side. But we're not done yet, are we? What do we have to do next?
Divide 2 by
Divide 2 by both
both sides.
sides?
2 extra by both sides.
Divide what? Thank you, Julia. Divide both sides by 2. And then you can just leave it like it is. 2 doesn't go into 5 an integer number of times, a whole number of times. So we're going to say our solution is a positive and negative 5 halves, which happens to also be known as what? What's its mixed number name? 2 and a half. So our parabola should cross the x-axis at what? Positive 2 and a half?
Both negative 2.
And negative 2 and a half. Now, here's the other option we have, or, and I want you to do this because I don't want, you know, you're looking at somewhere sometime and you're like, that isn't how LeGrand taught us to do it. The other thing we can do is when we're at this stage where we have 4x squared equals 25, we can get the x squared to be a 1x squared by doing what to both sides? Dividing by 4. Well, when we divide the left side by 4, we have x squared. Does 4 go into 25 a nice number of times? No. But, so there's no reason to change it to a mixed number because that's going to make it so ugly. It's not going to be any fun to work with. Let's just leave it like it is. Because now, to get x out of x squared, I have to take the square root of x squared. If I take the square root of x squared, I have to take the square root of 25 over 4. Now we got to remember that property that says when you're taking the square root of a fraction, what are you really doing?
So squaring both the top and the bottom.
Yeah, take the square root of both the top and the bottom. So what this really becomes is the square root of 25 over the square root of 4. And then don't forget about our plus minus. Because if we take the square root of x squared, we get x. If we take the square root of this, we are going to get a positive negative, but of course we're still not done. But we better end up with the same answer. Because now we're going to say, oh, well, then what is the square root of 25? 5. What's the square root of 4? 2. Do we get the same answer? Yes. We just went about it a little bit differently. Which one do you like better? One on the left? First one? I kind of do too. It's, seems like it's a little less work, doesn't it? But in reality, we can also take square roots of fractions. It's okay. We really can do it. So we don't want to be afraid that if we actually do divide both sides by 4, now the problem can't be solved. Okay, questions on anything we worked on in front here? Do we have more on the back? Of course we do. Okay, any questions on this side? Okay, then let's go to the back. Oops, I must have done it. Oh, okay, wherever you are. There we go. What do you suppose is the first thing we should do in this? Get the x squared alone? Yeah. Because we can't take the square root of 9x squared plus 100. Even though it looks kind of friendly right now, we're thinking, hey, well, wait a minute, that looks really friendly. 9x squared is a perfect square, 100 is a perfect square. Why not take the square root of that side? Wouldn't it be 3x plus 10? Because whatever we get, remember, multiply times itself, it has to get you back. So if we thought this could be taken this, you don't need to do this in your notes, just stay with me. If we thought we could do this and we said, well, you know what? I think I can do it. It's going to be 3x plus 10. But remember that multiplied by itself has to, we're not even going to worry about the other side right now. That multiplied by itself has to get us back to 9x squared plus 100. Do you think 3x plus 10 times 3x plus 10 would get us back to 9x squared plus 100? Have you foiled that out? Anybody think they know what that is, foiled out?
It would be 9x squared plus 60x plus 100.
You're right. It would be 9x squared plus 60x plus 100. We created a 60x that was never there. So, well, what if though? Well, so you say, well, you know, you've been talking about this plus minus thing, so let's make one of them positive and the other one negative. When you take the square root of something, doesn't it have to be something times itself? Yeah, so we can't do that either. So you know what? We got to ditch the idea that we can take the square root of that side. We need to get that 100 moved out of there. That's our first move. We need that 9x squared by itself. What's 75 take away 100?
Yeah, 25.
Negative 25. Well, those of you who were concerned that 75 wasn't a perfect square, wait a minute, maybe now we have a perfect square. Isn't 25 a perfect square? But
Yes, it is, but it's negative.
negative. So we would show, you know, we would go like this. We would say, okay, I'm so smart. I have my perfect squares memorized and 25 is in the list. But then after we put that square root symbol around it, hopefully right then and there we would stop and say, cannot take the square root of a negative number. Let's put that in our notes. Cannot take the square root of a negative number. Well, if you cannot take the square root of a negative number, what's that mean? No solution. We gotta have an answer. What is the solution? Well, there aren't any x values that make it true. There are no places it crosses the x-axis. What do you think this parabola would do without putting in bracket calculators? What would it do? It would open up? Okay.
It'd be linear.
It'd be linear? How would it get linear? I thought it had x squared in it, it was quadratic. Didn't it? Aren't there some x squareds in this one? Yes, no, maybe? Yeah, 9x squared, there's some x squared, it's gotta be quadratic. And it's gonna open up as long as we, you know, leave that 9x squared on the left side. If we move the 75 over and said, okay, I'm gonna have 9x squared plus 25 now, because I gotta subtract it from both sides. I have 9x squared plus 25. It's gonna open up, what else? It's not going to touch the x-axis, is it? Its vertex is where? You don't have to be specific. Where's that? Above the x-axis. Yeah, it's above the x-axis somewhere. It's never going to touch the x-axis, this parabola. So that's what this is telling us. You will eventually learn, well then how do I solve a problem like this? Right now we get to say no solution. Okay, this is the other situation that can happen. You have a factor times itself. So x plus 3 squared means x plus 3 times itself, yeah. And then on the other side we have this 49. Oh, is that 30 squared? Nice, no reason to move it over then. Let's go to right to work taking the square root of x plus 3 squared and taking the square root of 49. When you have a factor times itself, this is what you get to do. You get to take the square root. And if you do it to one side, you got to do it to the other. Well, what is the square root of x plus 3 times itself? X plus 3. It's x plus 3. What is the square root of 49?
Plus negative 7.
Awesome. Positive and negative 7. Well, that means right now, x isn't by itself, is it? So that means this x plus 3 can be equal to a positive 7, and this x plus 3 can be equal to a negative 7. So we need to break it up like that now. We can't just leave it with that shortcut. We have to say, oh, well, since x isn't by itself, I now need to break it up and subtract 3 from both sides in both of them. And we end up with x equals,
Positive.
be careful. Be careful. 7 take away 3 is 4. Negative 7 take away 3 is negative 10. Ooh. Oh, they can be, they don't have to be opposites of each other. And I'm going to guess the reason that they're not opposites of each other is because of that plus 3 there. Let's go put that on the graphing calculator and make sure we're right. Okay, so here's what we're going to do. We're going to put in, let's go to y equals first. In y equals, I want you to put in x plus 3. You need to do parentheses. Parenthesis x plus 3, parenthesis. Square that. Subtract 49, so we're going to get that 49 over there with it. And let's go to our window key. So we have the x plus 3 in parentheses. Outside the parentheses, we've squared it. We've subtracted 49. Now we're going to go to our window key. And we're going to put for x min, we're going to put negative 10. X max, we're going to put, actually for x min, go back to that one, we're going to put negative 15. For x max, we're going to put 10.
Wait, what? For x min, we're going to put
Negative 15. Window, x min, negative 15. X max, positive 10. X scale, 1. Okay, and then for the y min, we're going to put negative 100. Negative 100. And for the y max, we're going to put positive 20. And for the y scale, we're going to go by tens. Y scale 10. Graph. So is it crossing at positive 4 and negative 4? Is it crossing at positive 10 and negative 10? Go to the table. Verify that we have the right solutions. When x is equal to 4 in the table, is y equal to 0? Okay, go to negative 4. Go to x equals negative 4. The opposite of 4. You know, you wanted it to be that. How about at negative 4? Is y equal to 0? No. So is that a 0 then? No, that can't be a solution then. How about x equals negative 10? Yeah. How about x equals positive 10? It's opposite. What if x equals positive 10? Is y equal to 0? No. Okay, so here's what your brain's going to want to do. Your brain is going to get in the habit of thinking that when you're using the square root method, the solutions will be opposites of each other. Not always. Sometimes, but not always. So don't just write down, you know, like this work and then like what you guys were going to doing. You said it's going to be positive 4 and negative 4. It's going to be positive 10 and negative 10. And neither of those were right. We found out it's positive 4 and negative 10. Can you do the last one on your own? See what happens. What do you get? Where are you going? What are you doing? What are we doing now? Here.
Right there.
You need to, oh, you were still back there? Okay. Why don't you catch up with number...
I wrote it down, but you wrote it in the wrong place.
Oh, you put it in the wrong spot. So where did you do this one in it?
Right there.
Oh, here. Oh, so this is...
Yeah,
this
just wasn't
is
paying
there.
attention.
Okay, good job. Okay. you have a factor times itself, in other words, when you have a factor times itself,
It'll be well, opposite of each other. You don't have the extra number of the extra constant.
so when you get to just take the square root of an x squared term, so like here, if you have just an x squared term, and you can take the square root of that, there's not a factor times itself, or maybe even and of course on that side, we couldn't do it. X squared equals 121, we got opposites. X squared, that one we couldn't take the square root of. Look at this one, after we got the 25 moved over, we got opposites of each other, because we did not have a factor times itself then. Now, be really careful though. What do you think would happen if we had a factor times itself? So I'm going to make up a problem here. What if we had this problem? X plus 2 squared equals 0. What do you think would happen there? Would the solutions be opposites of each other there, maybe, because it's 0? Any predictions? What do you think? How are solving this? What do you think? Yeah, the solutions would be opposites there.
It'll be the opposites.
You think they'll be opposites? So we have two solutions that'll be opposites of each other. Anybody think there'll only be one solution? What's the square root of 0? 0. Did we talk about 0 being positive or negative? No. So if we were solving this one, if we took the square root of x plus 2 squared, and we took the square root of 0, what would this side's square root be? The x plus 2. What would this side's square root be? 0. We don't have to do a positive and a negative 0 because 0 doesn't have a sign. So we would subtract 2 from both sides. X equals negative 2. It only has one solution, doesn't it? Only has one. How would you put that in the graph calculator? What do y equals? In parentheses, after you clear out the one that was in there in parentheses, put x plus 2. After you close those parentheses, I want you to square it. And then I want you to just go and do a zoom 6. Zoom 6. What's happening on this graph?
It's good. The vertex stuff is making.
The vertex is sitting at negative 2 on the x-axis. Remember, when there's only one solution, it's the vertex sitting on the x-axis. So, we have to be able to start reasoning out why we get, some of the solutions we have, and we do get, and what that would mean on the graph. Remember, I told you to be putting all these pieces together all the time. Okay, anybody have any questions? Okay, then let's go put those graphing calculators away and then get your assignment started.